All right, everybody. So what we're going to do right now is we're going to talk about what makes statements equivalent. This is a great opportunity to practice doing truth tables, which we have been focused on up to this point. And our unit is taking us to the point where we want to be able to see if an argument is valid or not. Now, this video is a little different than other ones I've posted. I'm not in class, so I'm going to leave it up to you when I say to pause the video, to go ahead and pause the video and work exercises and then press play to see how it goes. That is very important for you to learn, to be able to write down and to imprint your memory through the process of writing. There's lots of science behind that. So here we go. Two statements are called equivalent. And that is symbolized with an equal sign with 3 bars. If both have exactly the same truth values in the answer columns. So this is just an exercise. I'm doing a truth table. So exercise 1 right here, this one is for you. So go ahead and push pause. And what I would like you to do is on this big truth table, I'd like you to form the truth table for P and in parentheses Q or R. And I want to know, is that equivalent to, yes or no, P and Q in parentheses or P and R? So go ahead and push pause now, work that problem. And when you push play, you'll get to watch me. All right, we are back. So here we go. First thing I'm going to do is I'm going to fill in the truth values for my truth table with 3 simple statements. And the process that I've given you is just to do this. Statement P, go ahead and do 4 trues and then 4 falses. Statement Q, go 2 and then 2. And then finally, statement R, alternate every other. True, false, true, false, true, false, and then true, false. And so what I'm going to do is first my truth table for P and in parentheses Q or R. So parentheses, just like for arithmetic, mean I'm going to start there. So I'm going to start with Q or R. I'm going to do a column for that. And remember, or the disjunction is true when either one of my statements is true. So I'm going to go down the Q column and the R column, and we're going to see which ones are true. So I've got true or true, so that is true. True or false, at least one of those is true, so true. False or true, same thing. False or false, neither one of those is true, so that is false. True or true again, true or false, false or true, false or false. Remember, these are all just based on the truth table facts. I know that there's 8 rows here, but it is no different than what we were doing when there was only 4. So if you need to review the basic truth table facts in your Canvas shell, there is a basic truth table video. It's short, it's like 5 minutes. There is a practice sheet. Print as many of those as you need to and just practice, practice, practice. It's like learning your multiplication tables. Okay, so now what I'm going to do is I'm going to say, okay, now we're going to take that column, the Q or R column, and we're going to use the and statement, the conjunction, to unify it with P. So here's the P column right here. So I've got 4 trues, 4 falses. I'm going to join it with the Q or R column right here. And remember, a conjunction is true only when both are true. So the first one, we've got true and true. So that's true. True and true again. True and true a third time. True and false, that's false. The last one, since each one of these last 4 starts with a false, that means we've got 4 falses. So here we go, false, false, false. So that is the column for P and Q or R. All right, now that I have that, I'm going to do the same process for the other statement, P and Q or P and R. And so just going to go through this. Again, this is an and statement, P and Q. And statements are true only when both statements are true. So I'm going to go down the P and the Q column. So true and true, good. True and true, good. True and false, that one's going to be false. True and false, that's going to be false. And each of these last ones is going to start with a false once again. So that's going to make the conjunction false in each of these cases. And my pen is running out of ink. Sorry about that. Let me grab another one and finish those last couple falses. So there we go. There we go. Now I'm going to do the same thing for P and R. So P and R, I've got true and true, true and false, true and true, true and false, false and true, false and false, false and true, false and false. And last but not least, now I'm going to take both of these red columns, P and Q, and I'm going to use the disjunction, the or, with the other one, P and R. Remember the or statement, the disjunction is true when either one is true. So here we go. True or true, that's good. True or false, one of those is true. False or true. And now all the rest of these are both falses, so the disjunction is going to be false in each of these cases. All right, so all that was practice of truth tables. None of that was new information. Here's the new bit. What I want to know is, are those two things equivalent? So what I'm going to do is I'm going to look at both final columns. I'm going to put an asterisk here. I'm going to put an asterisk there and compare. They're both exactly the same row by row. There is absolutely no difference. And so what we would say is, yes, these two things are equivalent. All right, so now we will go and do this same sort of process with a statement with words. This is my example, so you don't have to pause the video. We are going to select the statement that is not equivalent to Miguel is sick or on vacation. So here's what we're going to do first. What we're going to do is we are going to put all of these statements into symbols. Okay, so Miguel is sick or on vacation. So here we go. What we're going to say is that P is equal to Miguel. I'm just going to use a capital M, is sick. Pardon me. I think something needs to be shut off here. So first, I'm going to just say the simple statement P is Miguel is sick. The simple statement Q is that Miguel is on vacation. So first, the statement that I am working with, Miguel is sick or on vacation, is P or Q. Okay, I'm going to write that down here. That is P or Q. Great. Now, the next one, A, if Miguel is sick, then he is not on vacation. So that's an if-then statement. So that is if Miguel is sick, so P, then not on vacation, squiggly Q. Okay, so P, then squiggly Q. That's the next one we're going to do our truth table for. Miguel is on vacation or sick. So that Miguel is on vacation is Q, or Miguel is sick, that's P. So Q or P, that's the next one we're going to look at. If Miguel is not sick, so squiggly P, then he is on vacation, then Q. And the final one is if Miguel is not on vacation, so squiggly Q, then he is sick, P. All right, fantastic. So again, this is just an exercise in doing a truth table. And so here we go. First off, I've got a truth table with 4 rows. So this is going to be true, then true, true, then false, false, then true, false, false. Those are my 4 options. The first column is just a straightforward disjunction, P or Q. The disjunction is true when either one is true. So we've got true, we've got true, we've got true, we've got false. Now remember, we are interested in which one is not equivalent. So let's go ahead and see. So first off, I've got P, if P, then not Q. Probably should have left myself a little room to do a squiggly column, so I'm just going to have to do that over at the end. I apologize. I should have probably left a little room earlier. So Q is true, false, true, false. So squiggly Q is false, true, false, true. And so if P, then Q, remember the order matters here. The only time the conditional statement is false is if you have true, then false. So let's see, P, then squiggly Q. So that's true, then false. Okay, that's the false one. True, then true, that's true. False, then false, that's true. False, then true, that's true. Okay, you can see right away, this is a different column than my original one. So right now, which one is not equivalent? Well, A is not equivalent. Let's see if other ones are not equivalent. Q or P, that's a disjunction. The disjunction is true when either one is true. So true or true is true. True or false True or false? False or false? What that shows us, that's equivalent to the other column. What that shows us is it doesn't matter what order you do the disjunction in. The next one is the statement squiggly P then Q. I need a squiggly P column, so I'm going to throw that on at the end. Squiggly P is going to be false, false, true, true. It's the opposite of the P column. So squiggly P then Q. So that is false, then true. That is true. False, then false. That is true. True, then true. That is true. And true, then false. That is false. And we see that that is equivalent to my original. So I'm just going to put check marks under the ones that are equivalent. We saw that the second column wasn't. And then here is my last one. The last one is squiggly Q, then P. So here's the squiggly Q. Here's P. So I've got false, then true. That's true. I've got true, then true. That's true. False, then false. That's true. True, then false. That's false, and that one is equivalent. So the only one of those four statements that is not equivalent is the first one. All right, we're going to flip the page. I would like you to do the same thing. So this is an exercise for you. What I would like you to do is go ahead and push pause on your video and go ahead and do the same process that I just did. And when you come back, we will talk through the answer. All right, so I'm assuming you've pushed play again, you've worked the problem. So here we go. What I've done is I've defined the two simple statements. P is the statement, it is raining, and Q is I need a jacket. So my original statement is if it is raining, then I need a jacket. So if P, then Q. So I'm going to be a little smarter this time than I was on the last problem. I'm going to put a squiggly P right here and a squiggly Q because I'm guessing I'm going to need them. And so then I have my first column P, then Q. And what I want to know is which ones are not equivalent. So we're going to go through each of these statements and we're going to write them down and we're going to see which one. So it is not raining or I need a jacket. So it is not raining is squiggly P. Or is the disjunction, I need a jacket Q. So squiggly P or Q. The next one is I need a jacket or it is not raining. So that is Q or not P. The next one is if I need a jacket, then it is raining. So that's Q, then P. And then last but not least, if I do not need a jacket, so that is squiggly Q, then it is not raining, squiggly P. There's my squigglies that I need, and we've got it. Okay, so let's go through on this one again. My simple truth table is going to be true, then true, true, false, false, true, false, false. And so here we go. Firstly, I need my squiggles. So squiggly P is just going to be the opposite of P, so I will do just the opposite. Squiggly Q is the opposite of Q, so I will do the opposite. And now I need if P then Q, that is the conditional statement. So remember the conditional statement is true except for when you have true then false. So here we go. True then true, that's good. True then false, that is the false one. False then true, and then false then false. Okay, that's true. So that is my original statement. I want to know which ones are not equivalent to that to answer this question. So the next one is squiggly P or R. The disjunction is true when either one is true. So squiggly P or R. So, squiggly P or Q. Squiggly P is false. Q is true. It's true. Squiggly P is false. Q is false. Squiggly P is true. Q is true. And then squiggly P is true, Q is false. That's true. So that is the same as the previous column. So it is equivalent. Q or squiggly P, well, you see, this is just the previous column reversed. So I'm just going to, it's the same thing. Doesn't matter what order you do the disjunction in, and you can go through that. The next one, we reverse the order, Q then P. So we're going this way now. We're going from right to left on my column. So Q to P. So true then true. False then true, true then false, false then false. And we see, okay, that one is different than the original column. So C is definitely different. That is not equivalent to the original statement. And then just for good measure, let's check this last one. Squiggly Q, then squiggly P. So squiggly Q, then squiggly P. So false, then false is true. True, then false is false. False, then true is true. And true, then true is true. And we see one more time that that is equivalent to the first statement. Okay, so what this example brings up for us is you notice on this one that my original conditional statement, P then Q, was the exact same thing as squiggly Q then squiggly P. I reversed the order and I negated both of them. So I want to know, okay, is there a way that I can apply that? And the answer is yes. We are going to look at conditional statements and their equivalences. So I have just created a couple of statements. I've tried to create the shortest possible statements that I can so that we're not writing all day. And these conditional statements are P, it rains, and Q, I get wet. Okay, so very, very impactful statements right there. So what we're going to do is we're going to write the 4 different types of conditional statements. Okay. So the first one is just the plain old conditional that we're used to, if P then Q. And so what I invite you to do, since we have talked about conditional statements, since we have written them in words, pause the video, take 30 seconds, and write these 4 things: P then Q, Q then P, squiggly P then squiggly Q, and squiggly Q then squiggly P. Write those all in words for me. Okay, I trust that you pushed pause and you are back. So let's go ahead and write these 4 statements. The conditional, if P then Q, is if it rains, then I get wet. Okay, that happened to me at Epcot on Friday, so I know that that is a true statement. Okay, the converse. I'm going to now just flip the order. So now I've got the Q first, then the P. So this says if I get wet, then it rains. What we're going to answer in just a couple minutes is, are these 2 things equivalent? Don't know. The next one is, instead of changing the order of P and Q, I've just negated both of them. So I have squiggly P and squiggly Q. So this is if it does not rain, then I do not get wet. Again, is this equivalent to my original statement? I don't know. That's what we're gonna see. That's gonna be the very next thing that we do. And finally, the contrapositive. I have reversed the order of both statements. Q is first and then P, but I've also negated both. So this is if I do not get wet, then it does not rain. So I hope you took the time to write those out. It's good practice, something we're going to continue doing. So we're going to flip the page. We got one more page on this little section about equivalences. What we're going to do in exercise 3 is you are going to create a truth table, and you are going to determine which of those 4 statements are equivalent to one another. So first thing you're going to do before you push pause is we are going to fill in our truths and falses. We'll probably need a squiggly P column and a squiggly Q column. And then you need a column for each of these things. We need an if P, then Q. That was our original statement. Then we saw that the converse was if Q, then P. We'll need a column for that. Then the inverse was we negated both of them, but did not change the order. So squiggly P, then squiggly Q. And then finally, the last one is squiggly Q, then squiggly P. Okay, these are just the 4 statements from the previous page. And now what I would like you to do, please, is push pause and go ahead and complete the truth table for that. And let's determine which statements are equivalent to one another. Okay, we're back. I hope you pushed pause. So let's see how we do right here. So first thing is I need a column for squiggly P and squiggly Q. So squiggly P is false, false, true, true. Squiggly Q is false, true, false, true. My Conditional statement, P then Q. Remember, any conditional statement is always true unless you have the situation true then false. So P and Q, true then true. That's true. True then false. That's false. False then true. That's true. False then false. That's true. Okay, that's my original conditional statement. That's the one I'm really super interested in. Now, what happens when I reverse the order of the statements? Okay, Q then P. So now we're going backwards. So I've got true then true. Okay, good. Then I've got false then true. That's true. Then I've got true then false. That's false. Now I've got false then false. So we see that this thing that I call the converse, this is not equivalent to the original statement. So I'm going to put an X under there. The converse is not equivalent to my conditional statement. The next one, the inverse, where I keep the statements in the same order, but I negate both of them. So squiggly P, squiggly Q. So here's squiggly P and squiggly Q column. False then false. That's true. False then true. That's true. True then false. That is false. And then true then true. That is true. Now notice two things here. My inverse is not equivalent to my original statement, which is what I'm interested in, but the inverse is equivalent to the converse. Okay, and we're going to see that relationship again. Okay, this relationship that I'm pointing to is the same one that we're going to see in these last two, because spoilers, these last two are going to be equivalent to each other. But this is the same relationship, just with different orders. So squiggly Q then squiggly P. So false then false is true. True then false is false. False then true is true. And true then true is true. And we see this column is the same as this one. And what we've just shown is that the contrapositive, that fun word to say, the contrapositive is the same as my conditional statement. So what that means is if I flip the order and I negate both, then I end up with something that is logically equivalent to what I started with. And notice my converse and inverse, these are also just contrapositives of each other because I flipped the order of the statements and I negated both of them. Okay, so that's why these two columns are equal to each other. So I have one more example, and then you have a few problems that you are going to do as we finish out this section on equivalent statements. So example 2, what we're going to do is we're going to rewrite the conditional statement as the equivalent contrapositive. So what that means is I am going to take the statement, I am going to write it symbolically, and then I am going to flip it around using the contrapositive. And again, the contrapositive is I change the order of both statements, and then I negate both statements. So example 2 says this: if the quadrilateral is a parallelogram, then opposite sides are parallel. Okay. So writing just kind of in an abbreviated form, statement P is the quadrilateral. The quad is a parallelogram. Statement Q is opposite sides are parallel. So opposite, I'm going to abbreviate, sides are parallel. Okay, so that means the original statement is if P, then Q. Well, looking up at the table above, okay, what is the contrapositive? Well, the contrapositive, okay, is this. I'm going to flip the order of the statements, and then I'm going to negate both. So instead of Q, I'm going to have squiggly Q over here. And then instead of P, I'm going to have squiggly P right there. And now I'm just going to write this in words. So what this says is if the opposite sides are parallel, if squiggly Q, then the quadrilateral is not a parallelogram. Okay. So we're just going to practice that a couple more times so that you get the gist of this. So what I would like you to do is exercise 4 right down below. Go through those same steps. Here is our statement. If you live in Los Angeles, then you live in California. Write that symbolically. Use the contrapositive and then rewrite it. So go ahead and push pause and do that. All right, so once again, I hope you pushed pause and did that. You're not just going to write down what I do because that doesn't help you at all. Learning is about go ahead and you might have to struggle through. You have to create those neural pathways, but that will help you remember. So here we go. Statement P is going to be you live in Los Angeles. And then statement Q is going to be you live in California. So what that means is my original statement, if you live in Los Angeles, then you live in California, is P, then Q. Again, from the truth table at the top of our page, the contrapositive is what you get when you flip the order and negate. So instead of Q, I'm going to have squiggly Q. Instead of P, I'm going to have squiggly P. And now I'm going to write that in words. And so that says, if you do not live in California, then squiggly P, you do not live in LA. Those two statements, the first one and the one we just wrote, are logically equivalent. Okay, same thing, exercise 5. It's the same process. I've just put in some extra negations here for fun. So go ahead and give this one a try, please. Okay, statement P. If you do not have clean clothes, then it is time to do the laundry. So statement P is you have clean clothes. Remember, we always define statements positively. Then it is time to do the laundry. There's my two simple statements. P is you have clean clothes. Q, it is time to do the laundry. So my simple original statement is if you do not have clean clothes, so that's squiggly P, then it is time to do the laundry. Q. This is the reason I gave this example is I want to be able to form the contrapositive when I have a negation in my original statement. And so again, the contrapositive is you flip the order and you negate. So instead of Q, I'm going to have squiggly Q. And then instead of squiggly P, I'm going to negate and I'm going to have P. That's the contrapositive. And now we just write that in words. If it is time to do the laundry, if it is not time to do the laundry, then P, you have clean clothes. Then you have clean clothes, which are always good. I have clean clothes right now. All right, one final problem. Okay, push pause, do this one more, give it a little practice, and then we will be done with this section. So this final problem says, if you are watching Shamu, then you are not at Disney World. So P is you are watching Shamu. And Q, remember, we always define our simple statements positively. So instead of you are not at Disney World, we're going to say you are at, and I'm going to abbreviate DW for Disney World. So that means my original statement, if you are watching Shamu, so P, then you are not at Disney World, squiggly Q. Once again, the purpose of this problem is forming the contrapositive when you already have a negation. So the contrapositive is you flip the order and you negate. So instead of squiggly Q, I'm going to have Q. And then instead of P, I'm going to have squiggly P. And that is the contrapositive. This is the logically equivalent statement. And so now, what is this? It is if Q, if you are at Disney World, then P, or excuse me, if you're at Disney World, then squiggly P, you are not watching Shamu. All right, and there is a little bit about equivalent statements in logic.